Alright, here we go. So here is a key for today's assessment. I know it challenged you, but here you go. Here's how I kind of would reason through it. You're given a quadratic. This one here is sitting in standard form. Standard form. Okay, so I'm going to put it in to the other forms. I'm going to put it in factored form, assuming it's factorable, and this one is. And then I'll go ahead and I'll put it in vertex form. I'm going to go with factored first. And you know, I wasn't thinking about how big these numbers would get. I know this is a negative 105. So you're going, oh my gosh, negative 105. Two things that multiply to negative 105 and add to 8. That's kind of hard. And it kind of is. You know, one thing I noticed off the bat, though, is I know 5 goes into 105 21 times. But yeah, 5 times 20, you know, 5 plus 21, I'm not going to get to 8. You know, let's, even if this was negative 21. But, you know, 21 you can do like 7 and 3. So you've got 105 down to its prime factors. So that says, okay, so that means that 5 times 7 times 3. Or I could do 5 times 3 times 7. Or I could do, you know, 7 times 3 times 5. So what combination, how am I going to get, you know, 7 times 3 times 5, that's like 21 times 5. This one here, that's 15 times 7. Oh, 15 and 7, yeah. 15 and 7, if one of them is negative, I can get to 8. So let's see, the 15 is going to be positive, so 15x minus 7x. So you split the middle term. 3x squared plus 15x minus 7x minus 35. Now we just factor by grouping. So you take this first group. 3x can be taken out. You're left with x plus 5. If this thing is factorable, there's going to be an x plus 5 over here. So is there anything I could take out? Yes. I could take out a minus 7. You know, minus 7 times x minus 7x minus 7 times 5 minus 35. Cool, so I've pretty much got it factored, right? You're going to take out now the x plus 5, and that leaves the 3x minus 7. So that's, we got it factored form. Now we got to go to vertex form. Well, you know, vertex form on this one is going to end up looking like 3 parentheses x plus or minus something squared and plus or minus a number. I know the 3's there because of this 3 right here. So if you knew the vertex, if you knew the coordinates of the vertex, you could fill in this number and this one. So I feel like my job has really changed to, okay, what's the easiest way to find the vertex? And you know, you could use completing the square here, but you know what I'm going to do is, well, I know that the vertex, the x of the vertex is negative b over 2a. Okay, that's our line of symmetry. So vertex, the x is negative b over 2a. Now when you get that, you're going to plug negative b over 2a into your function, and whatever your function spits out, that'll be your y-coordinate. So negative b over 2a, so b is 8, right? This is a, b, c. b is 8 over 2 times a, which is 3, so 6. So you got, oh, and b was 8, so it's negative b, the opposite of b. So negative 8 sixths, negative 4 thirds. Okay, so the vertex is, you know, normally with x squared, the vertex is at 0, 0. This thing got an x coordinate of negative 4 thirds. That means this 0, that went left 4 thirds. So if you're going to go left 4 thirds, you're going to have x plus 4 thirds right here. That's a shift left 4 thirds of a unit. So now you just need the y coordinate. Okay, so the x is negative 4 thirds. So if I plug negative 4 thirds into my equation, what do I get? Alright, well, I can already see I should have given you more room, and I apologize. So let's pretend like number 2 isn't there right now. So negative 4/3 into the equation. So you got 3 negative 4/3 squared plus 8 times negative 4/3 minus 35. So you got 3 times 16 over 3 times 3. Those will cancel. Plus negative 32/3 minus 35. So we got 16/3, we got negative 32/3, and we got minus 35. Minus 35 is minus 105/3. So let's see, I got a 16 and a negative 32 and a minus 105. Well, the 16 and the negative 32, that's going to leave me with negative 16. And negative 16 and negative 105 is negative 121. So minus 121/3. That's the y of the vertex. Negative 121/3. So the vertex, 121/3. The vertex is at negative 4/3, negative 121/3. So normally the vertex is at 0, 0. So if we, if we think transformations, I got to go left 4/3 and down negative, or down 121/3. So you got a 121/3, and that is your answer in vertex form. I'll pause this real quick. Okay, so I think we're good on this problem. Right? We got it in factored form. That's this answer in yellow. And we got it here in vertex form. Oh, right here, right below it. That's your vertex form. That was kind of hard, right? You had some messy numbers to deal with. And, a way to check your answer, obviously, would be if you graphed both of these, all three of them, they should produce the same graph, in the same table. So maybe I'll put this on pause and I'll do that real quick. So I'm glad I checked, and you guys are probably already looking at the mistake I made. Yeah, I dropped a sign. Right here, yeah, these we were finding the y-coordinate of the vertex right here, and we agreed that it was negative 121/3, which I wrote up here. And then we even talked about shifting this thing left and down, but if it's going to go down right there, that's a minus. So, silly mistake on my part. Okay, we got number 1 done. Now let's go to number 2, which I've got blacked out here. So let's show that one. Alright, so we start with it in vertex form. So let's say we want to put this one in, we'll go standard form first, okay? So if you're going to expand this, 2x minus 4, x minus 4, minus 2. Well, let's see, x minus 4 by x minus 4. So this is x. So you do this x times x minus 4. That's another way you can see it. X times x minus 4. Minus 4. So this green one here, minus 4 times x minus 4. There's so many different ways you can organize this. Really 4 multiplications are going to happen. So you got x squared minus 4x minus 4x plus 16. So that's x squared minus 8x plus 16. And all of that work was just for this. So you got the 2 on the outside and a minus 2 here. So 2x squared minus 16x plus 32 minus 2. 2x squared minus 16x plus 30. So now we've got it in standard form. So now you'd want to factor that. Okay, I think the easiest way to factor that would be first recognize that 2x squared has a factor of 2 in it, minus 16x has a factor of 2, and 30 has a factor of 2. It would work if you don't take it out, but you could take out a 2. And now when you do this deal, when we split the middle term, so what multiplies to 15 and adds to negative 8? Negative 3, negative 5. So we take out a common factor of x. 3, I'm going to have an x minus 3 over here. What can I factor out so that I have an x minus 3, and that would be a minus 5. So factored form, let's see, this is an x minus 3 and an x minus 5. So that takes the place of this. So don't forget your 2 out front. So factored form would be 2x minus 3, x minus 5, factored form. So you got vertex form, you got standard form, you got factored form. So there's your vertex, there's your standard, there's your factored. One more. Of those variety, right, you start in factored form. Well, I notice when I start in factored form that my the zeros are x equals 4, x equals negative 7. So let's say I want to go to vertex form first. Halfway between those zeros will be the x-coordinate of the line of symmetry. Right? Any parabola, if it crosses the x-axis, halfway between the zeros, right? Halfway between those values will be the x-coordinate of the vertex. Well, halfway between negative 7 and 4, well, you go negative 7 plus 4 divided by 2. That's negative 3 halves. So you have the x of the vertex, right? Let me make a note. X of vertex. Well, if you want to get the y, you just plug it in. So 2 negative 3 halves minus 8 times negative 3 halves plus 7. So those 2's cancel. So negative 3 minus 8 is negative 11 times, let's see, 7 is 14 halves. So that would be 11 halves. So negative 11 times 11 halves is negative 121 over 2. And that's the y of the vertex. So if you multiplied this one all out, you'd have a 2x squared plus all that stuff. Which is fine, we'll need to do that in a little bit. But the fact that that's a 2, you know the x of the vertex, you know the y of the vertex, you can put this thing in vertex form. Vertex form is going to be y equals 2 parenthesis, let's see, it's left 3 halves, so x plus 3 halves squared minus 121 over 2. And that is in vertex form. Okay, in standard form, you're going to have to multiply this out, right? Showed you a couple ways to multiply this out. So you're going to go, I'm going to go, let's say, 2x times x plus 7 minus 8 times x plus 7. 2x squared plus 14x minus 8x minus 56. 2x squared plus 6x minus 56, standard form. Okay, I'm going to hit pause and check my answers. But I got factored form. Oops. Factored form. I need to say this, factored form. I got my factored form. I got my vertex form. I got my standard form. So I'm going to plug all three of those into y equals in my calculator, look at the table, and make sure they all match. Alright, good deal. They all matched. Okay. Part 2 of the assessment was about transformations of quadratics. So you want to get from g of x to f of x. Well, if g of x was in vertex form, life would be easier. You could see how the quadratics really differed. So I'm going to put g of x in vertex form. A couple ways to do that. So g of x, that's like y equals x squared minus 8x plus 1. Well, that's like, that's equivalent to y minus 1 equals x squared minus 8x, which is equivalent to y minus 1 plus 16 equals x squared minus 8x plus 16, which is equivalent to y plus 15 equals x minus 4 squared, y equals x minus 4 squared minus 15. So you want to go from the yellow to the green. Okay, so what would you replace x with so that you ended up with an x minus 5? Well, x is going to become x minus 1. So that's a shift right 1 unit. Now, you've got minus 15, and you want to end up with plus 1, so how many do you have to add? You're going to have to add 16. So that's going to take you up 16 units. That's 4. 5 is similar but different. And I made it a little harder, and I wanted to see how this turned out. So we've already said this is equivalent to x minus 4 squared minus 15. So what do you do to g of x to make it f of x? Okay, well, if I multiply g of x by 4, that would give me minus 60, right? So I like the fact that the 4 is there, and I'm going to say my first step is multiply by 4. So vertical stretch by 4. But that changed how much I'm going to have to shift this thing vertically by. Because I'm at minus 60 and I need to get to plus 1, so I'm going to have to add 61. So I'm going to say vertical shift up 61. And once again, I've got x minus 4. I want x minus 5, so x is going to become x minus 1. So if you let x become x minus 1, you'll shift it right 1 unit. So I'd say those 3 transformations. 6, I really like 6. 4 quadratics in standard form that all have the same line of symmetry. Doesn't mean you have to only write them in standard form. So I'm going to come up with 4 quadratics in vertex form that have the same line of symmetry. Okay, so let's say if you have the same line of symmetry, you have the same x of the vertex. So like x minus 5 squared, x minus 5 squared plus 1, x minus 5 squared plus 2, x minus 5 squared plus 3. They all differ by a vertical shift, but they have the same x coordinate of the vertex, right? They're all a lot like x squared, except they're, right 5 units. And then they differ by vertical shifts. So, same line of symmetry. So if you multiplied this out, this would be x squared minus 10x plus 25. Well, this is the same as that, right? So you're just going to add 1 to it. So the green plus 1 is x squared minus 10x plus 26. Same. X squared minus 10x plus 27. X squared minus 10x plus 28. So they all have a different c value. And we've learned that c has nothing to do with the line of symmetry, right? Line of symmetry, I mean, that's just x equals negative b over 2a. c has nothing to do with that. Nothing at all. So there are 4 quadratics in standard form that all have the same line of symmetry.